All right. Let's recap the progression of stuff we've done so far. Okay, up until now, I give you an equation. I give you a function. And then what do you do with it? Up until now, what have you done with this equation? Solve it. Yeah, so when you solve it, you go from here to what? To factoring, if possible. So then we start off with our x's. Look at the second sign. It's a plus. That tells us what? Same sign, and it's always the first sign. So they're both plus. Then we look at the last number and figure out, give me two numbers that multiply to give equal 6, that when I second sign the two numbers, I get the middle number. So I get 3 times 2, 3 plus 2, and it doesn't matter where they go. And then what do we do with this? Set, very good. Set the equation equals 0, and then set each of these two equal to 0. And then we solve our equations. So far, so good. Now, they have names. What is this level called? What are we finding here? Very good. Factors. Those are the factors. What are these? Zeros. Excellent. Or solutions or x-intercepts or anything like that. When we use the quadratic formula, we put it in this equation. Label A, B, and C, plug them in there, and then we end up with two answers. Does this help us finding the factors? Let's try it again. Does this help you? If you did what? Very good. So these, if we start off from our solutions, how do we get the factors from there? Set them equal to 0. So we add 3 to both sides. Right. We write them this way. Now we have our factors. So no matter what what method we use, we can always find the factors. So that helps us, even though you wonder what good are factors. Well, what good are factors is to break down a polynomial into certain smaller pieces, so we can look at them. We'll need those whenever we do division of multiple polynomials. All right. So let's see here. Let's start with Theorem 1. The fundamental theorem of algebra. Ever heard of the word theorem before, besides Pythagorean theorem? What is a theorem? More than just a guide. It is a guide, yes, but it's more than a guide. It's kind of like here's like we have to follow laws with driving and everything like that. This is a law of mathematics. It's true. It's always going to happen. This is how, if this exists, then this is going to be the answer if you do it this way. But the fundamental theorem of algebra says every polynomial p of x function of degree n, where n is greater than or equal to 1, that should be easier for you, has at least 1 0 in the set of complex numbers. I was going to say can be factored into two binomial terms that can result in, that's too much work. This is much easier. So what does this mean? Every polynomial, p of x, what's a polynomial? Multiple terms. Is x squared a polynomial? Yeah, it's a monomial. That's a polynomial of degree n. Why does n have to be greater than or equal to 1? What would it look like if it was degree 0? If what would that graph look like if it was degree 0? What's the rule for anything degree of power 0? So if it's degree 0, it's a horizontal line. Anybody know y to the power 0 equals 1? I don't think we went through this. Let's look at the rules. The rules of exponents say this. If you have the same base and different exponents, we can combine them by adding the exponents. So if I had x cubed and x squared, how many x's do I have? If I have 3 there and 2 there, how many do I have multiplied together? So if I had x cubed times x squared, this one says I have 5x's. Is it true? X times x times x times x times x. How many x's do I have? 5. So that's a rule. There's another rule that says if we divide, because when you multiply, you make things bigger. That's why you're adding them. When you divide, you make them smaller, and you take the top power minus the bottom power and subtract them because they cancel out. What if I had the same exponent top and bottom? First off, what does that equal? If you have the same number top and bottom, what does that equal? 1. Using the rules of exponents, this rule, what do I get? If I take the top exponent minus the bottom exponent, what is n minus n? So there you have it. That's why anything to the power 0 is always equal to 1. So that's why it's important to have your degree greater than or equal to 1. If it's 1, if n equals 1, then it's a diagonal line. Y equals x. And what does the degree tell us? What is the purpose of a degree? What does it tell us? The degree tells us the maximum number of solutions possible. And what are the other words that we can use instead of solutions? What's that? Zeros, factors, x-intercepts, and roots. So those are all the words of that. Well, what this thing says is any polynomial function p of x with degree greater than or equal to 1 has at least one zero in the set of complex numbers. Because you have to have one x to have 1 0. If you have three x's, you can have 3 zeros. But if you have no x's, how many zeros do you have? And because it's a horizontal line, there's no x-intercepts. Now, what does a complex number look like? What does a complex number look like? Well, it is any number, but what's the basic format of it? It's what? But what's the formula for it? Yeah. It would be for you. That's the general formula for it. Where A and B are any real numbers. We talked about this in chapter 3 when we talked about real numbers or complex numbers, I mean. So all of your factors, in other words, if you have a polynomial which looks like this, that's a polynomial. It has a degree greater than or equal to 1. It has at least 1 0 in the set of complex numbers, which means I can now take this number and factor it down into linear terms, linear factors. Each one of these are complex in form. In other words, they could be real numbers, they could be imaginary numbers, or a combination of real and imaginary numbers. So that's what this is saying. I could take any polynomial and I could factor it down to its individual answers. We just did that up here. I took any polynomial, I factored it down to these. That's what it's saying. That's the fundamental theorem of algebra. It took us 4 chapters to get this far. All right. Let's see how this works. That's what this whole section is about. Finding polynomials with given zeros. What do you think that means? With given zeros. What do you think given zeros means? A zero is a what? X solution, x-intercept. So if I say the x-intercept is at 2 and at -3. If those are my x-intercepts, my solutions, my zeros, what is my polynomial? Another way this could be asked is a polynomial function has zeros at 2 and -3. What is the polynomial function? So we start off with this, set them equal to 0. In other words, move them over. And now multiply them together. X times x is x squared, positive 3x, negative 2x, negative times positive is negative, 2 times 3 is 6. 3 minus 2 is 1, positive 1. So my polynomial function is this. It's the first example we just did. If I give you the zeros, you can tell me the answers, where it came from. So you start off from here, from this x equals whatever, set them equal to 0, set those two equations equal to 0, multiply them, and there you have it. We're just working backwards. Find a polynomial function of degree 3 having the zeros 1, 3i, and negative 3i. So I gave you the zeros, then we know that x equals 1, x equals 3i, and x equals negative 3i. Those are my zeros. Those are my x-intercepts. Set them equal to 0. Now what do? What's that? Yeah, now I multiply them all together. X plus 3i. And set that equal to 0. Now I multiply. Multiply the imaginaries first. X times x is x squared. Positive 3xi. Negative 3xi. Positive, negative is negative. 3 times 3 is 9. I times I is I squared. since I got rid of parentheses, first thing I do is combine like terms. The 3i negative 3i cancel. And I squared changes the sign of the number in front of it. Because what does I squared become? -1. So we had -9i squared. That becomes -9 times -1. That becomes +9. So instead of going through all that stuff, I squared just changes the sign of the number in front of it and get rid of the I squared. That disappears. Now multiply again. X times x squared is x cubed. X times +9 is +9x. Negative positive is negative. 1 times x squared is x squared. Negative times positive is negative. 1 times 9 is 9. Rearrange them so it's in decreasing order. And there's my polynomial function of, that's 3. My polynomial function of degree 3 with those zeros. Let's see. Now, what would this graph look like? It'd be an increasing function. It'd be cubed. It's cubic. Let's do it over here. It's cubic. What are my intercepts that I know of? Is where? So I said, yeah, I said -9. What else? Right. It gave me one of them is at 1. So we know is our graph will look something like this. There's no other exception. And it's a cubic function, so opposite directions. Also, did you notice in the last one, our zeros were at 1, 3i, and -3i. What is noticeable about that we talked about last week about complex numbers? What's different about those two? The sign. What is it called when they have different signs? Same numbers, different signs. Hmm? Ooh, no. Good thought. No. Whenever you deal with imaginary numbers, they're called complex conjugates. What's a conjugate? Well, opposite what? Opposite sign. A complex conjugate is if I have one answer that's A plus BI, I have to have another one. I have to have one. They have to come in conjugate pairs. Complex solutions and radical solutions must come in conjugate pairs. So with this last example, if I would have just given you these two x-intercepts, and I've told you it's degree 3, you know you're supposed to have 3 answers, only gave you 2 of them, that's an imaginary, so we should know automatically that we're missing a negative 3i. Or if we have a solution that's 2 minus radical 5, what's its conjugate? That's 2x, 2x plus radical 5. The conjugate just changes the sign between them. Example 2. Find the polynomial function of degree 5 with negative 1 as a 0 with multiplicity 3, 4 as a 0 of multiplicity 1, and 0 as a 0 of multiplicity 1. Before we do anything further, with this information, can you tell me what the graph is going to look like? What's the graph going to look like? What's the end behavior? Why? Right, because degrees 5, we know that the end behavior has to be different directions. Since it doesn't tell us anything about the coefficient, we're presuming it's positive. So it'll look like this. What are my x-intercepts? Negative 1. What else? 4. These are my x. What else? And then 0. Those are my x-intercepts. And I know the graph has to look like this at the ends. So at negative 1, is it going to bounce or is it going to cross? Why? Right. At negative 1, the multiplicity is 3, which is odd, so it crosses. What does it do at 0? Cross or bounce? Why does it cross? Odd multiplicity of 1, so it crosses. And it has to cross at 4, so it looks something like this. We know the graph without even knowing the function, really. So let's look at the polynomial function. So what's my first 0? X equals what? Negative 1. What's my next 0? And the last one, 0. So my zeros are -1, 4, and 0. So what my equation looks like is x plus 1, x minus 4, and x. And the multiplicity of the -1 is 3. The multiplicity of 4 is 1. And the multiplicity of x is 1. You notice, what things students forget is that if there's an x by itself, that's an intercept. That's an answer. Anywhere you see an x, you put a 0. So if I was asking you to solve these for the x-intercept, if I gave you this and asked you my x-intercepts, you have to take all 3 of these and set them equal to 0. Students forget the constant x value. So now what do? I'm looking for my polynomial. So it's x plus 1 times x plus 1 times x plus 1 times x minus 4. Since I'm looking for the polynomial, I'm not done until I get an equation. So I'll do the first 2 together, and I'll do the last 2 together. And then I'll multiply them all together. So in this first one, we have x times x is x squared plus x plus x plus 1 x squared minus 4x plus 1x minus 4. Combine like terms, x squared plus 2x plus 1 x squared minus 3x minus 4. Hopefully everybody doesn't have to bobblehead their way through this one. You could do it yourself. So my next step is x squared plus 2x plus 1 x squared minus 3x minus 4. Now I multiply these 2 together. X squared times x squared is x to the 4th. Positive times negative is negative. X squared times x, there's 3, it makes it x cubed. Positive times negative is negative. 1 times 4 is 4, x squared. That does it for that one. Positive times positive is positive. 2 times 1 is 2. X times x squared is x cubed. Positive times negative is negative. 2 times 3 is 6. X times x is x squared. Positive times negative is negative. 2 times 4 is 8 times x. Positive times positive is positive. 1 times x squared is x squared. Positive times negative. 1 times 3 is 3x. Positive times negative is negative. 1 times 4 is 4. Again, nobody should be bobbleheading. You should be able to do this yourself. What's my next step? combine like terms. So start with the highest. How many x to the fourth is just that one right there. So that's that one. X cubes. We have -3 and a +2. So -3 plus 2 is -1 x cubed. So that takes care of those guys. Next is x squares. -4, -10, +1. So -4, -6 is -10, plus 1 is -9, x squared. Now the x's, -8, -3 is -11 x's, and then -4. Is anybody having trouble with this with the multiplication here? The distributivity property? What's my last step? Multiply everybody by x. X times x to the fourth is x to the fifth. Positive, negative is negative. X times x to the third is x to the fourth. Positive times negative is negative. 9 times 1 is 9. X squared times x is x cubed. Pretty much all you're doing is adding 1 to all the x's. Negative times positive is negative. 1 times 11 is 11. X times x is x squared. And then the last one is 4x. So that's my polynomial equation. What's that graph going to look like? Is that already? See if anybody's listening. Me. Any questions so far? Now let's remember I said about complex conjugates, conjugate pairs. What is a conjugate pair? Little bit more to it than that. Opposite signs where? Imaginary term or the radical. In other words, if I had a plus bi, I just change the sign in front of the bi. So it's a minus bi. Because I could have -2 plus 3i. What is its conjugate pair? -2 minus 3i. All you do is change the sign in front of the imaginary number. Same with the radicals. 2x minus radical 5, it will become 2x plus radical 5. So that's what a conjugate pair is. All right, so let's start looking at those. Example 3. Suppose the polynomial function is of degree 6 with rational coefficients has -2 plus 5i, -2i, and 1 minus radical 3 as 3 of its zeros. Find the missing zeros. All of the clues are in there right here. What do these represent? These represent my zeros. These are my solutions. How many of them am I supposed to have? I'm supposed to have 6 of them, but I only have 3. So which ones are missing? What's missing for this one? -2 minus 5i. That's the first one. What's missing for this one? 2i. And the last one? Right. These are my 6 zeros. And imagine putting that equation together. This is how you would do it. You would have to take each one of these and set them equal to x. Because that's what this part tells us. These are my solutions, my x-intercepts, my rational zeros. Now I gotta set these equal to 0. So I gotta move everything over. So it's x. This one's gonna be +2 minus 5i equals 0. So there's my first parenthesis. X plus 2i equals 0. There's my second parenthesis. X minus 1 plus radical 3 equals 0. There's my third parenthesis. X plus 2 plus 5i equals 0. There's my fourth parenthesis. X minus 2i equals 0. There's my fifth. X minus 1 minus radical 3 equals 0. Does everybody see how I get those numbers, those equations? Because whenever you move something from one side to the other side, what do? Just change the sign. Now, imagine multiplying these together. Let's look at the first one. If we multiplied these first two together, let's say we just multiply these two together. How much fun would that be? Let's see. X times x is x squared. X times 2, 2x. X times negative 5i is negative 5xi. That's it for the x. 2 times x is 2x. 2 times 2 is 4. 2 times negative 5 is negative 10i. That does it for this one. 5i times x is positive 5xi. 5 times 2 is positive 10i. Positive negative is a negative. 5 times 5 is 25. I times I is I squared. How many terms should I have here? How many? How many terms does this one have? How many terms does this one have? And they're multiplied, so 3 times 3 is, I should have 9 terms here. Before I simplify. Now let's simplify. I only have that x squared. Here's a 2x. There's another 2x, so that's 4x. We have negative 5xi, positive 5xi, so they cancel. Here's a negative 10i and a positive 10i, they cancel. So we have a positive 4. What does this one become? Yeah, this one changes the sign. So it becomes a positive 25. So there's my polynomial. That that's just for the first ones. We got to do the same with all of these other ones and then multiply them together. I wouldn't do that to y'all. So you see, we have to do this 3 more times, 4 more times. Here's an unwritten rule. Number of terms in a polynomial equation is equal to n plus 1. Of course, it could be less, but this is typically, let's see. What does n represent? N is the degree. So let's say we had a linear equation. A linear equation is mx plus b. How many terms are there? 2 terms. Let's say we had a quadratic equation. So ax squared plus bx plus c. We have 3 terms. That's what I said. That's why it's n plus 1. So if n was 6, then we have how many terms? If n was 6, right, we had 7 terms. Why is it 1 more? Because we have that constant at the very end. So that's why. Example 4. Find a polynomial function of lowest degree with rational coefficients has negative radical 3 and 1 plus I as 2 of its zeros. So anybody gonna take a guess of what degree the final answer is going to be? I'm gonna get a cricket sound for my phone right here. 4. So what do we know so far? We know that x is equal to negative radical 3, and we know that x is equal to 1 plus I as 2 of its zeros. Anytime you have radicals or imaginaries, you have to have its conjugate pair. So what is the conjugate pair of the first one? Root 3. What's the conjugate pair of the second one? 1 minus I, right. So those are our 4 terms, our 4 zeros. Are we done? No, because it wants us to find the polynomial itself. So what do we have to do with these 4 x's? Not yet. Set them equal to 0. So x plus radical 3 equals 0. There's my first parenthesis. X minus 1 minus I equals 0. There's my second parenthesis. X minus radical 3. That's my third parenthesis. x minus 1 plus I equals 0. That's my fourth. For those of you who aren't going to ask, why did I get x minus 1? I'm going to get this one. So x equals 1 minus I. To get rid of the 1, I subtract 1 from both sides. X minus 1 equals negative I. To get rid of the I add I to both sides. So it's x minus 1 plus I equals 0. That's what that is. So whenever you move something to the other side, just change the sign. So my polynomial so far looks like this. X plus radical 3, x minus radical 3, x minus 1 minus I, x minus 1 plus I. Let's treat both of these separately for right now. X times x is x squared. X times negative radical 3 is negative x radical 3. Positive x radical 3. Positive times negative is negative. What's radical 3 times radical 3? Yeah. Well, it's going to be radical 3 squared, which is going to be 3. The middle terms cancel. Square root and the square cancel, so it just becomes 3. Yes.
It said that 1 plus I has 2 zeros. Would that make that one squared?
Which one? And the second one we're going to do?
In the example, it said 1 plus I has 2, but it's zeros there. Would that make that function?
No, what it's saying here is 2 of the zeros. This is 1 0. This is another 0. Which that means we're just missing 2 more. Now the next one, since we have 3 here and 3 here, this next one's going to have 9 terms before we simplify it. X times x is x squared. Negative x plus xi. Negative 1 times x is negative x. Negative 1 is a positive 1. Negative 1 times I is negative I. Negative I times x is negative xi. Negative makes a positive I. Negative I squared. Don't do what I'm doing here. Cram it in such a short area. Use all the paper you need so you don't make a mistake writing down things. Because that'll be the worst thing you can do is make a mistake because you ran out of space. Now what do? Combine, yeah, whenever you get rid of parentheses, combine like terms. So how many x squared? I just have that 1x squared there. We have a negative x, a negative x. That makes it negative 2x. Positive xi, negative xi cancels. Negative I, positive I cancel. So we have a plus 1. Negative I squared becomes what?
-1 or
Positive. Because I squared is negative 1. So it's negative of a negative 1 makes it a positive 1. So our polynomial so far becomes x squared minus 3, x squared minus 2x plus 2. One more time. You see, I mean, I can't apologize enough, but that's what's happening here is we will have more and more and more of these things. And this is not all the writing we do. Wait till the next part. We're going to do a lot of synthetic divisions. So now what do we do? Now we got to multiply these two together. So P of X is equal to X squared minus 3, X squared minus 2X plus 2. X squared times X squared is X to the 4th. X squared times negative 2X, so it's negative 2X cubed. X squared times positive 2 is positive 2X squared. That one's done. Negative 3 times X squared is negative 3X squared. Negative and negative makes it a positive. 3 times 2 is 6X. Negative positive is a negative. 3 times 2 is 6. Now combine like terms. We only have negative 2X cubed. Bless you. X squared, 2X squared minus 3X squared is minus 1X squared plus 6X minus 6. That's my polynomial of the lowest degree possible. Note. If this way is confusing, there's another way. When you multiply multiple polynomials together, you could stack them on top of each other. For example, X squared times X squared is X to the 4th. X squared times that is negative 2X cubed. X squared times positive 2 is positive 2X squared. Now, in the next one, negative 3 times X squared is what? So I put it under the X squares. And then I have negative 3 times negative 2 is negative 6X. Or negative is a positive 6X. Then negative 6. This way, just add straight down. Some students find that easier. So negative 3 plus 2 is negative 1X squared. So that way you don't have to go searching around on your list to see where it is. So if this is easier for you, please do that. Stack them on top of each other. Okay. Now let's do the culmination of all this sort of stuff. What if I gave you this? And asked you to find the factors of it. Factor this one. Okay, you'll see that you can't use the quadratic formula. You can't use grouping. Why can you not use grouping? They have nothing in common. You can't do anything else. So whenever you use grouping, you have to make sure once you factor something out, you have the same numbers inside the parentheses. So that doesn't work there. So how do we go about doing this? I wish I had. Let me see our other examples here. Are there any simpler ones? Before we jump into, yeah, I'll use those. Yes. Before we jump into this one, let's look at this one. X cubed minus X squared plus 9X minus 9. We're going to use something This is called the rational zero theorem. The rational zero theorem says this: given any polynomial given any polynomial consider a rational number P over Q where P is the constant term and Q is the leading coefficient. Then the factors of P of X will come from the factors of P over Q, plus or minus P over Q. Okay, that sounds pretty strange right now, but once you see what matters. Okay, remember, how many, if I ask you to factor this using synthetic division, remember, if you use synthetic division, how do we know if it's a factor? The remainder is zero. So how many numbers can you choose to see if you can find the factors of this? Infinite. They can be positive, they can be negative, they can be fractions, they can be imaginary, they can be radicals. There's infinite number. So this method helps us break it down to a smaller set of numbers. So now we have to, what is P? P is the constant term. That's 9. Just a 9. Don't worry about the negative sign. What's Q? Q is the leading coefficient, and that's 1, the number in front. What we have to do is find the factors of both of those. What are the factors, possible factors of 9? So it can be made up of 1 times 9 and 3 times 3. So the factors are 1, 3, and 9. The factors of this one is just 1. So far, so good? So take the constant number, break it down to what are the possible numbers that multiply to equal that. Now we're doing the ratio of them. And it could be the positive or negative of those numbers. So we take each of the top numbers and divide it by the bottom one. So it could be 1 over 1, 3 over 1, or 9 over 1. So we can have a plus or minus 1, plus or minus 3, or plus or minus 9 as our possible zeros. All right, so it could be -1, +1, -3, +3, -9, +9. So if your answer, your polynomial the factors, the solutions are integers, these will be them. It'll come from that list. Now, once we find 1 or 2 or 3, whatever's left, we can find another method to figure out the rest of them. So how do we start? Start with the first one and use synthetic division. It's 1, -1, 9, -9. Bring down the first term. -1 times 1 is -1. Add straight down. -1, -1 is -2. Multiply this number times the bottom number. So -1 times 2 is 2. Add straight down, that makes it 11. Repeat, -1 times 11 is -11. This makes it -20. It's not 0, so -1 is not an answer. Is 1, now we do the next one. Is 1 a possible answer? 1, -1, 9, -9. Bring down the first term. And repeat. 1 times 1 is 1. -1 plus 1 is 0. 1 times 1 is 1, or 1 times 0 is 0. Add 9 plus 0 is 9. 1 times 9 is 9. 9 minus 9. So x equals 1 is one of my solutions. How many answers are we expecting? We're expecting 3 answers. We just found one of them. Now, we're done with this equation. All we have to do now is use these numbers from now on out. Or, what is this equation going to look like? What is this equation since there's 0 in the middle? Remember, this is the constant, this is the x, this is the x squared. So what this equation looks like is x squared plus 9 equals 0. X squared plus 9 equals 0. Do we have to keep on doing synthetic division? Or can we use another method at this point? Well, since it only has 2 terms, x squared plus 9, we can use the square root method. Subtract 9 from both sides. We have x squared equals -9. Square root both sides. What are you left with? Plus or minus. Whenever you square root something squared, you have to put a plus or minus there. That becomes an I. What's the square root of 9? So these are my 3 solutions. So what are the factors of my polynomial? So remember, our polynomial was x squared minus 2x, x cubed minus x squared plus 9x minus 9. What are the factors? X minus 1, x plus 3i. Very good. So there's the factors. Once you find the intercepts, you can find the factors. So far, so good? Okay, now we introduced this method. Because remember, we went from originally, we went from infinite number of possibilities. We narrowed it down to 6 possibilities. Once we found the ones we needed to, we found the rest of the answers. So this method speeds it up. Let's go back and do this one now. This, no, because in this thing, you take a positive and negative it. So all we need is just the number itself. So let's look at this one again. This example 5. Our polynomial is p of x, 3x to the 4th minus 11x cubed plus 10x minus 4. What's p and what's q? Four is p, and then q is 3. So this is my q, this is my p. What can 4 factor out into? What are the multiples of 4? 1 times 4 and 2 times 2. So 1, 2, and 4. We look at all possible combinations of what 2 numbers multiply to give you 4. How about 3? 1 and 3. Very good. So now what we do is we take all the numbers on the top and divide it by each one on the bottom. So we have first one, we have 1 over 1. It's plus or minus. We have 2 plus or minus 2 over 1. Then we have plus or minus 4 over 1. Then we have plus or minus 1 over 3. Plus or minus 2 over 3. And then plus or minus 4 over 3. So my possible answers, 1 over 1 is 1, 2 over 1 is 2, 4, 1/3, 2/3, and then 4/3. So we went from infinitely many to how many possibilities? No. They're each, yeah, there's 12. There's a plus or minus each one, so there's 12 possibilities. So think about it. We went from infinitely many down to 12. And at most, we're looking for 4 solutions. So let's begin. The first number we try is, let's say, positive 1. How do we set up our synthetic division? Remember, you have to allocate the numbers for each of these x's. Since the highest is x to the 4th, we need x to the 4th, x cubed, x squared, x, and constant. Those are where the coefficients go. 3, negative 11, 0, 10, and negative 4. You cannot forget that 0 because it needs to be allocated. That's why you start from the highest exponent and count all the way down to the constant. Bring the first term down. Multiply 1 times 3 and put it here. Add straight up and down. 11 minus 3 is 8, so it's negative 8. Multiply 0 plus negative 8 is negative 8. 1 times negative 8 is negative 8. 10 minus 8 is 2. 1 times 2 is 2. So 1 is not a solution. How about negative 1? -1 times 3 is -3. -11 plus -3 is -14. -1 times -14 is +14. Plus 0 is 14. -1 times 14 is -14. -14 minus or plus 10 is -4. -1 times -4 is +4. -4 plus 4 is 0. So here's my first solution. So we know that x equals 1 is one of my solutions. X equals -1 is one of my solutions. Now, once you find a 0, don't move on to the next number. Try this one again. Why? You could have a multiplicity. So I'm going to try -1 again. But this time, I only use these numbers. So bring down the first term. -1 times 3 is -3. -14, -3 is -17. -1, -17 is +17. 14 plus 17 is 31. It's going the wrong direction. So -1 only happens once. So we try the next number. Let's try 2. So we finished the ones. Now we try 2. So it's 3, -14, 14, -4. Bring down the first term. 2 times 3 is 6. -14 plus 6 is -8. 2 times -8 is -16. -16 plus 14 is -2. 2 times -2 is -4. Makes it -8. No. What will be the next number? Now we do -2 with the same numbers. 3, -14, 14, -4. So -2. 3, -14, +14, -4. Bring down the first term. Multiply. -2 times 3 is -6. -6, -14 is -20. -2, -20 is +40. Nope, we're going the wrong direction. So we know -2 doesn't work. Remember I told you earlier all the ones. Now think of how many more you have to go. I'm going to jump to since we're short of time, I want to finish before Christmas. Let's try 2/3 as the next solution. Let's try 2/3. So that means we've gone through positive -2, positive -4, positive -1/3. Now we're doing 2/3. Three, -14, 14, -4. Bring down the first term. This is where your skills have to come into play. Again, Practice using your brain first before you use a calculator. So 2/3 times 3 is what? 2. Because if you look at it, 2/3 times 3, the 3's cancel, so we just have 2. So we have negative 14 plus 2 is negative 12. So we have 2/3 times negative 12. 2/3 times negative 12. 3 goes into 12 4 times, so 2 times negative 4 is negative 8. 14 minus 8 is 6. 6 divided by 3 is 2. 2 times 2 is 4, gives us 0. So yay, we know that x equals 2/3 is our second answer. Remember, our first answer was negative 1. How many more answers do we need? 2 more. Remember, our polynomial was to the 4th degree. So let's find 2 more. Well, now look where we are right now. We don't have to do any more of these synthetic divisions. Now we're at 3x squared minus 12x plus 6. You only have 3 terms, so it's quadratic. We can factor out a 3, leaving us with x squared minus 4x plus 2. Since we factor out a 3, that also has to go in our final answer, since we factor out a 3. How do we solve this one? Let's use the quadratic formula. What am I doing? X equals negative b plus or minus b squared minus 4ac over 2a, where a equals 1, b equals negative 4, and c equals 2. So we have negative of negative 4 plus or minus negative 4 squared minus 4 times 1 times 2 over 2 times 1. Now, again, hopefully everybody knows how to use the quadratic formula. So I'll do this pretty quick. Negative and negative 4 is a positive 4. Negative 4 squared is 16. 4 times 1 is 4, times 2 is 8 over 2. Four plus or minus 16 minus 8 is 8. Remember, 8 is made up of 2 times 4, which is 2 times 2. So this becomes 2 square root of 2. Again, we've done that how many times in the semester? The square root of 8. On the top, what do they both have in common? They both have a 2. So I can factor out a 2 on top. Those cancel. So my last 2 answers are x equals 2 plus radical 2, x equals 2 minus radical 2. Those are my 4 answers. What do we have example? So far, so good? We're not done yet. Because what are our x-intercepts? Our x-intercepts are x equals -1, x equals 2/3, x equals 2 plus radical 2, x equals 2 minus radical 2, and then we also had a number 3 out in front. Because the question is asking for us to find the polynomial. It's asking for us to find, where's that? Where's that one? Find the rational zeros and the other zeros, and then factor into linear factors. So actually, so all this one wants us to do is this. 3, this becomes x plus 1 equals 0. So it's x plus 1. Now, whenever you have something like this, most people will say, let's make it x minus 2/3. But make it look nicer, it's got a fraction. Multiply both sides by 3. So this one becomes 3x minus 2 equals 0. Then it's x minus 2 minus radical 2, x minus 2 plus radical 2. Those are the factors in the polynomial into its linear factors. It's not asking for the complete function, is it?
It's
Yeah, yeah. Thank you. Yes. So no, I'm not going to multiply it. So there's your answers. All right, let's look at another one. Example 6. Given this polynomial, 2x to the 5th minus x to the 4th minus 4x cubed plus 2x squared minus 30x plus 15. Who would have thought 2 weeks ago that you could have any idea how to find the solutions to this one, something like this? Just think of how much we've theoretically progressed in 2.5 weeks. So what this says is find the rational zeros and then factor them into linear factors. So what's my first step? What's my P over Q? What is P? P is the constant, 15. What is Q? 2. So what numbers multiply to give you 15? Right. 1 times 15 and 3 and 5. What numbers multiply to give you 2? 1 and 2. Now we got to put them in the rational zeros. So we take all the numbers on top divided by the bottom numbers. So we'll start with 1. So we have plus or minus 1 over 1, plus or minus 3 over 1, plus or minus 5 over 1, plus or minus 15 over 1, plus or minus 1 over 2, plus or minus 3 over 2, plus or minus 5 over 2, and plus or minus 15 over 2. The reason we do this is just in case when you do the fractions, if it simplifies to something we've done already. So in other words, like you can have 3 or you can have 6/2. They're the same thing. You only do it once. So our possible answers are plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, plus or minus 1/2, plus or minus 3/2, plus or minus 5/2, and then plus or minus 15/2. Again, this is a lot less than doing it by trial and error. Even though we have 1, 2, 3, 4, 5, 6, 7, 8, we have 16 possibilities. It's much less than infinity. So let's start. We have 1. So x to the 5th, x to the 4th, x cubed, x squared, x, and constant. So we have 2 minus 1 minus 4, 2 minus 30, and 15. Those are my coefficients. Bring down the first term. Start the process. 1 times 2 is 2. 2 minus 1 is 1. 1 times 1 is 1. Negative 4 plus 1 is negative 3. 1 times negative 3 is negative 3. Plus 2 is negative 1. Negative 1 plus negative 30 is negative 31. Minus 15 is negative 16. So 1 doesn't work. Do the negative 1 also. I'll put it on pause and let you guys do negative 1. Negative 1 times 2 is negative 2. Negative 2 plus negative 1 is negative 3. 1 times negative 3 is negative 3. Or negative 1, negative 3 is positive 3. Negative 4 plus 3 is negative 1. Negative 1 times negative 1 is 1. 2 plus 1 is 3. Negative 1 times 3 is negative 3. Negative 30 minus 3 is negative 33. Negative 1, negative 33 is positive 33. The answer is 48, which means it's not a right answer. So these are not going to work. Let's go to 1/2. But you see now, on your homework, on a test, you have to go through each one of those so you find them. So bring down the first one. 1/2 times 2 is what? Is positive 1. Negative 1 plus 1 is 0. 1/2 times 0 is 0. Negative 4 plus 0 is negative 4. Negative half times negative 4 is, what's 4 divided by 2? What's the first number? I mean, what is it? Yes, somebody knows it. It's negative 2 in this case. 4 divided by 2 is 2, ladies and gentlemen. 2 minus 2 is 0. 1/2 times 0 is 0. Negative 30 plus 0 is negative 30. Half of negative 30 is negative 15. So x equals 1/2 is my first factor. Looking at this, we see they have a bunch of zeros. So if we were going to write this one out, what would be the x value for this one? It'd be 2x to the positive fourth, because we started off with 5 and we got rid of 1x right there. Then this would be x to the fourth, x to the third. This would be minus 4x squared. That would be x, and that would be my constant. What do we notice about this equation? It's quadratic in form, because the power here times 2 equals 4. And there's only 3 terms. So we can use the quadratic formula here. But before we do that, we can factor out a 2. So this is another number that we have to put in our factors. Actually, we need a quadratic formula for this one. What numbers will go in the first parenthesis? No. What goes here? No. In an equation, what are you always solving for? What part of it? In a quadratic equation, what are you solving for? The middle term. It's going to be x squared. What signs go in there? Because remember, this one times this one has to equal x to the fourth. Since the second sign is a minus, they're opposite signs. The bigger number gets the minus. What times what is 15? When you subtract them, you get 2. 5 and 3. So the bigger number gets a negative. So we set both of these equal to 0. X squared equals negative 3. X squared equals 5. So this one says x is equal to plus or minus I radical 3. This one says x is equal to plus or minus radical 5. Those are our last 4 factors. So those are my possible answers. I got to factor them out. So this is a fraction. Multiply both sides by 2. I get 2x equals 1. So 2x minus 1 equals 0. This is my first parenthesis. The 2 will go out in front. X minus I radical 3 equals 0, and x plus I radical 3 equals 0. That's what that one comes into. Because one's negative, one's positive. Same thing with this one. X minus radical 5, x plus radical 5. So my factors are 2, 2x minus 1, x minus I radical 3, x plus I radical 3, x minus radical 5, x plus radical 5. Those are my linear factors. Was anything introduced in this one that we haven't covered at least 3 or 4 times this semester? No. So again, that's the importance of staying current. Now, what we've done, we've went from infinitely many solutions. We've narrowed it down to plus or minus P over Q, the rational zero possibilities. Can we narrow it down even further? Yes. We could narrow it down even further, the number of solutions, by the number of positive solutions and the number of negative solutions. So let's say we had 15 possibilities here, and we know that we only have 4 or 2 or 0 positive solutions, 3 or 1 negative solutions. Once you find 3 of these negative solutions, you're done. Or if I only had 1 negative solution and I found it, I don't have to do any more negatives from here. That's the importance of this next one. It's called Descartes' rule of signs. You've heard Descartes before. He's the guy who invented the Cartesian coordinate system, the XY graph. He's also going to do here. Descartes' rule of signs tells you the maximum number of positive solutions and the maximum number of negative solutions, whether they're integers, imaginary, radicals, or not possibles. How is it done? By counting the number of sign changes in your polynomial and in your so this is the number of sign changes in your polynomial p of x, and if you change x to negative x. To use this, we cannot have any zero terms. We have to take everything into consideration. And the constant term cannot be 0. Let's see here. Let's look at this first one. Example 7. Two x to the 5th minus 3x squared plus x plus 4. Now, look at these, and then let's count the number of sign changes that we have. So the first one is positive, right? It's going to negative. Is that a sign change? Yes, that's one sign change. From negative to positive, is that a sign change? Yes. From positive to positive, is that a sign change? No. So we only have 2 sign changes. This tells us that we're going to have 2 or 0 positive solutions. Now, whenever you get a number here of sign changes, you go from there and subtract 2 until you can't go any further. Why do we subtract by 2? Because if one of your answers is imaginary, then there has to be the conjugate pair. That's why so it's just in case, if there's an imaginary or a radical, you have to subtract by 2. So let's say if we had 7 possibilities, we have 7, or we have 5, or we have 3, or we have 1 possible answers. It could be any one of those. All right. So whenever you get the highest number, subtract 2 and keep on going until you can't go any further. How about negative solutions? So we use P of X for the positive solutions. So we have to use P of negative X for the number of negative solutions. So here, just change the sign of the coefficients of odd degree terms. So our original one started off with 2x to the 5th minus 3x squared plus x plus 4. For the negative x, which ones change signs? Is this an odd or even number? Odd, so it changes sign. Odd or even? Leave it alone. X is odd or even? It's odd, but it's 1, so it changed its sign. And the constant. So now you count the sign changes. In this one, there's only 1 sign change. So what does that tell me? I'm only going to have 1 negative solution. Once I find my negative solution when I do the synthetic division, I can erase all the other ones that are negatives. I don't need those anymore. That's the beauty of this. Once you find your negative solution, you're done with all of them. We know the rest of them either have to be positive or imaginary, complex. So let's look at this. We know we can have a positive solution, a negative solution, and a complex conjugate. We can even have a 0 as a solution. How do we know we have a 0? If all the terms have an x in it. If all the terms have an x, then we have a 0. Because we can factor out that x. So they all have to equal 5. How many negatives can we have? 1. And then our positive solutions, we can either have 2 or 0. So if we have 2 positives and 1 negative, how many complexes can we have? Has to be 2. Because all these have to equal 5. So if we have no positives and 1 negative, then we have to have 4 complex solutions. Because it has to equal 5. Now, what does this mean? That means we're going to have either imaginary or square root answers. All right, let's look at the next one. P of x is equal to 2x to the 5th minus 5x squared minus 3x plus 6. How many positive solutions? Well, it's positive to negative, that's one. Negative to negative, nope. Negative to positive is one. So it's 2 or 0. P of negative x. So this in this equation, if it has an odd exponent, I change the sign in front of it. So I change this sign and that sign. So how many negative solutions do I have? Just one. So we have positive, negatives, and i's. They have to equal 5. So we can have 2 positives, 1 negative, which means we'll have 2 imaginaries. Or if we have no positives, 1 negative, then we have 4 of those. Everybody okay with this? Let's do another one. P of x is equal to 5x to the 4th minus 3x to the 3rd, 7x squared minus 12x plus 4. Give me number of positive solutions, negative solutions, and let's fill out our table here. Be positives, negatives, and i's. All right, how many sign changes are there for the positives? Is that a sign change? Is that a sign change? Is that a sign change? So we have 4 or what? Or 2 or 0. So the positives can be 4, 2, or 0. How many negatives do we have? So that one doesn't change. That one changes. That one doesn't change. That one changes. So any sign changes for negatives? No sign changes, so there's no negatives. So what does that do with our answers? With the rational zeros, we don't have to try any negatives. All we have to do is try positives. So we've cut them in half. And we're supposed to have a total of how many? So if we have 4 positives, no is negative. Do we have any imaginaries? 2 positives, no negatives. We have no positive, no negatives. We have like one real quick last one, because we have to look at if we have no constants. 6x to the 6 minus 2x squared minus 5x. Remember, you're supposed to have a constant, right? But we don't have a constant. What can we do? If you don't have a constant, That means they all have x's, right? That means we can factor out an x. So how many positive solutions can we have? Is that a sign change? Is that a sign change? So we have one sign change. And then we do the same thing with negatives. Is that a sign change? That a sign change? Now we also have to change this one. So this and this changes this makes it a positive. This and this makes it a negative. It makes it a positive. So how many sign changes? Two or zero. And we're supposed to have a total of how many? So I have a total of 6. So we have one positive, we have a 2 or a 0. Uh-oh, something's not right here. Can you have an odd number of negatives? Imaginaries? So there's something wrong. This is what's wrong. You can't, once you factor out, you can do that for the positives, but for the negatives, we have to go back over here. What signs change for the negatives? Does that one change? No, because it's even. Does that one change? No, it's even. The only one changes is this one. So we only have one sign change for negatives, which means we're going to have 4 of those. We're going to have 4 of those. So this has to be the only possibility is we're going to have 1 positive, 1 negative, and 4 imaginaries. So always refer back to the original equation. All right. Thank you, everybody. I'm sorry to keep you all so long.